Question is, for the given block diagram, we have to find out the transfer function. So, by Moson's gains formula, transfer function equals to, for first forward path is g1 into z2, second forward path is g2. If we remove the forward path, there are no individual loops as well as there are no individual two non-touching loops. Hence, the delta equals to 1. In the second case too, delta equals to 1. 1 minus first non-touching loop is g1, z2. There are no other loops. Comes to two non-touching loops, there are no two non-touching loops. Hence, the transfer function equals to g2 1 plus g1 divided by 1 minus g1 g2. Hence, option B is correct.
Look at this question now. He doesn't given any information which parameters it is. He has directly represented it as X. Okay, we have different two-port network parameters Z, Y. Okay, transmission parameters T, T dash, and H parameters and G parameters. Okay, it does not given any information regarding which parameter you have to find. Directly represented with S instead of Z, Y, T, T dash, H and G. People think that S represents short circuit or Siemens. Okay, when you see this one, he has given a characteristic impedance Z between these two ports. You can recollect one formula here. If two shunt elements are connected here, okay, now what is Y parameters for this network? Let us take this as YA, this is YC and this is YB. Okay, here it is port 1, this is port 2. Okay, now if you find Y parameters for this type of networks, this is YA plus YC minus YC minus YC and YB plus YC. You can note down this as a shortcut formula for Y parameters. Now for this two-port network, what is Y parameters here? 1 by Z minus 1 by Z minus 1 by Z and 1 by Z. Okay, if you look at this one here, you cannot find Z parameters since Z is equal to Y inverse. Okay, you cannot find Z parameters because determinant of Y is equal to infinity. Okay, so Z parameters you cannot find. This is not short circuit parameters. And if you see the relations, none of them is satisfying here Y relations. Okay, none of them are satisfying here Y parameters, so relations. This is not Y parameters Siemens. Now you take it as T parameters. If you find T parameters one, this is just like a short transmission line. Okay, T parameters is nothing but an ABCD parameters which is equal to 1Z01. Okay, you cannot find similarly H and G parameters. Okay, you can calculate it. H and G means V1 I2 is equal to H11 H12 and H21 H22 into I1 V2. Okay, write the relations and you can find that H parameters and G parameters also cannot be found. So what is this one? T parameters is equal to 1Z01. Okay, take it this one as S11, this as S12, this is S21 and this is S22, and observe the relations there. Okay, S12 is equal to option A. S12 is equal to 1 plus S11. Okay, option A is wrong. Similarly, what he has given in option B, this is also wrong. S12 is not equal to minus of S21. Similarly, option C, what is option C here? S12, that is Z is equal to 1 minus S11 is 1. Okay, so this is not equal to 0, or you can say not equal to Z. So this option is also wrong. Now look at the fourth option there. S22, that is 1, is equal to 1 plus S21, that is 0. So this one is satisfying. Option D is correct.
In this problem, the given function is f is equals to delta 2x cube y square z power 4. Now let us consider the function as phi, which is 2x cube y square z power 4, which is nothing but a scalar function. Now we have to find curl f. Curl f is nothing but curl of delta phi. Now we also know that curl delta phi is nothing but del cross del phi, which will be always equals to 0 for any scalar function phi. Therefore, curl of f is 0, which is nothing but option D. In this problem, it is given that A is a real matrix such that A power 67 is A inverse. Then we have to say which of the four options is correct. Now, let us consider the given condition. Consider the given condition, which is A power 67 is equals to A inverse. Now, let us multiply A on both sides. A into A power 67 will be A into A inverse. This can be written as A power 68 is equals to I. Since I is nothing but A into A inverse or A inverse into A. Now, if A power 68 is I, then mod A power 68 will be mod A will be equals to plus or minus 1. That implies modulus of A is nothing but magnitude plus or minus 1, which is option A.
Resistance of shunt for a precision grade ammeter can be best measured by. You can see four options there. Okay, directly you can eliminate two options. This is option B and option C. Maxwell bridge is for inductance and this is for capacitance. Okay, another two resistance bridges are Kelvin double bridge and Wheatstone bridge. Now which one we have to use out of these two bridges? Okay, now why we require shunt connections for ammeters? Okay, in order to increase the range of ammeters, we are going to use shunt resistances. Let us take the total current flowing in this one is 1000 amperes. Okay, you have an ammeter of 0 to 50 amperes range. That means this meter full scale deflection is 50 amperes. That means you have to divert remaining 950 amperes using this shunt connection. Okay, now let us take this ammeter 0.2 ohms. Okay, now what is the voltage across this one? Full scale deflection is 50 into 0.2. Okay, so this is 10 volts. Similarly, you have to connect a shunt resistance, that is 950 into RSH is equal to 10. So R is far less than meter resistance. Okay, you can say this is low resistance measurement. Okay, the low resistance measurement best suited bridge is Kelvin's double bridge, whereas this option D Wheatstone bridge is for medium value of resistances. Low value of resistance means it is less than 1 ohm. Okay, so you can measure the best bridge is Kelvin's double bridge.